Welcome to ePathshala PG courses on computer science. Today we will see about the next module where we will discuss about a concept called RMI. The objective of this module is to discuss about RMI and how it differs from other technologies. We will see in this module about the different layers in order to support RMI. We will also see that how to program with RMI basically using Java. So, RMI actually stands for remote method invocation. It is one of the it is like one of the technology of remote procedure call. So, this Java RMI is a mechanism which would allow the invocation of methods that are available remotely, or it is going to be on a different Java virtual machine. So, either this remote object is going to reside in a remote machine, or it can be in the same machine, but it can be in a different JVM, which means that it is available in it is running in a different address space. So, this RMI provides object oriented remote procedure call mechanism, and this actually supports JVMs that can reside on different machines, and the remote object could be on a different JVM running, and any method or any procedure can invoke this remote object that resides either locally in the machine, but running in a different address space, which means that it is in a different JVM, or the method can be running in a different server, which means that it is also running in a different JVM. So, here we can see that the methods can run in a different address space than the calling process. So, the calling process would be running in a JVM or in a address space, and the remote object is available in a different address space. So, it can be either in the local machine or it can be in a remote machine. So, RMI is basically a Java mechanism, or we can say that Java provides RMI, a remote method invocation mechanism, which is going to be a very easy and flexible way of invoking a remote object that runs in a different address space. So, this Java provides RMI in a different package, core package in the JDK 1.1, which would actually enable the software developers to write distributed applications using which we can invoke the remote objects that are running in a different JVMs. So, we have a separate package that supports this Java RMI in JDK 1.1. Now, let us see about what is this RMI, remote method invocation. So, it is actually an alternative to low level sockets. In the last module, we saw about TCP sockets and UDP sockets, by which we have communication, a client server communication between systems. Now, this Java RMI is another alternative to this low level sockets. The idea of this RMI is to have a remote procedure call, or we can say that we need to access a method that is actually running in a different machine, or it is available in some other system. So, instead of creating objects on the local machine, we can create some of the objects on other machines, which means that we can create objects on a remote machine, and we can communicate with those objects as we are actually normally doing with the local objects. So, the idea of RMI is to have remote objects that is running in a different address space if it is local to the machine, or it is going to be a remote objects that is running in a remote machine. So, using this RMI mechanism, one would be able to access the objects just like accessing a local object, which means that we try to access a method that is running locally in the machine. So, let us now see about how it differs from the other mechanisms. So, as I told you, Java RMI is an object oriented remote procedure call mechanism, but it differs from the another technology, an important technology, which is a competitive technology to RMI called CORBA. So, this CORBA is a language or machine independent, whereas when we look at Java, it is language dependent. RMI is language dependent, we mean that RMI has to be developed using Java. So, the other competitive technology, which is CORBA, is a language or machine independent mechanism, but this Java was designed for, this RMI was designed for Java running on a JVM. And we can see that this CORBA includes more mechanisms like server application starting, managing persistent state, support for transactions and so on. And even this CORBA assumes or would make use of an object broker that would actually handle this remote procedure call mechanisms, whereas Java does not have an object broker. And even this Java RMI differs from Sun RPC or DCE RPC, and we can see that this RMI is not language or mission independent, which we mean that it is language dependent and mission dependent, but it is not a platform dependent mechanism. So, this RMI supports the concept, using Java, RMI supports the concept of classes with methods within a class, and RMI also supports polymorphism. So, like Java programming, RMI is basically a package in Java which would allow us to make a remote procedure call. So, just like we work with Java classes and methods, we would also be able to work in RMI in Java. So, this actually differs from the CORBA, the basic RPC mechanism, which is a mission independent or a language independent mechanism. And now we can see the principal similarities between CORBA and RMI. So, we can see that both of these are suitable for distributed applications, development of distributed applications, or we can say that it is both of them are object oriented, both rely on an object oriented mechanism, and both supports a distributed client server systems. And we can see that both RMI and CORBA would allow synchronous interaction via remote procedure call, and this RPC is also implemented using stubs and client stubs and server skeletons, which would actually hide all the networking and data representation. And the client and the server, both of them are treated as objects. So, CORBA and RMI both are similar. There are similarities between these two technologies in terms of the application or the basic building block to develop a RPC using CORBA and RMI. But they too have some differences. CORBA and RMI have some differences. Let us see what are the differences we have. So, CORBA we can see that it is independent of the implementation language, but RMI requires all the objects to be programmed in Java. And in CORBA, if you take the operation invocations, they can be formed either statically or dynamically, whereas here you can see that in RMI, operation invocations are formed statically, and object implementations are binded in a static or dynamic way in CORBA, whereas here all the objects are binded as a static one. So, once a client a remote object is created, it would be bind statically to the registry when we look into a Java RMI. And the object implementation binding could also be static and dynamic in CORBA, whereas those bindings, mappings of names of objects would be static in Java. And we can see that the CORBA would make use of object adapters that defines the various object execution semantics, whereas here all the object services are defined within the enterprise Java beans. And we can also see that in CORBA we have many integrated object services, but RMI also supports many object services, but they are all written as enterprise Java beans, and Java RMI also supports a mobile code support. And now the goals of RMI. Here RMI supports seamless remote invocations on objects that are running in a different Java virtual machines, and this RMI has to support callbacks from servers to clients, and it has to integrate the distributed object model into the Java language. So, in order to, and without spoiling the semantics, and in order to retain the object oriented semantics of the Java language, the distributed object model has been created for RMI in order to support RMI in Java. And the differences between the distributed object model and the local Java object model are very apparent with with Java. And then when we write distributed applications using Java RMI, it is very simple and it is also very flexible. And in order to preserve the safety provided by the Java runtime, Java Sun real-time environment, this RMI also supports a little bit of security when comes to RMI. So here we can see that these are the different goals by which they developed the RMI mechanism in order to develop in distributed applications. So RMI was developed to provide a seamless remote method invocations, and it's very simple and flexible in writing an RMI or a remote procedure called code with Java language. And now coming to the different layers in order to support RMI is given in this diagram. We can see that there are two machines. One would be acting as a client system, the other would be acting as a server system. Now we have a remote object that would be running on the other machine. We can say that it is a different Java virtual machine. This different Java virtual machine can either reside in a local machine or it can be available in a remote server. So here you will have a client object in the local machine, and you have a remote object that is implemented in the other machine. Now we need to make use of two things called a stub object and a skeleton object. So the stub would be like a handle through which the client would be interacting with the services that is available in the server side, and all the services that are available in the server side for which you will have a skeleton. So in the client machine you will have a stub for the client object, and in the server machine you will have a skeleton for the remote object. And there would be a layer called remote reference layer that would be between the stub and the transport layer. It is available in both the client machine and the server machine. So you have a remote reference layer, and under that you will have a transport layer. This transport layer will make the marshalling of the data, marshalling of the data, which I mean that all the bytes of data, stream bytes, would be passed through the transport layer. So in detail, if you look into what is a stub. So stub is an object which actually provides a gateway for the client. So through this the client would be interacting with the remote object. So all the outgoing requests from the client would be routed through this stub, and the stub would reside at the client side and it would always represent the remote object. So for every remote object we need to have a stub in the client side that would act as a interface, or that would act as a handle to connect to the remote object. So what happens when the caller invokes a method on the stub object? So when the caller invokes a method on the stub object, it would initiate the following operations. So it is listed here one by one. First, the client stub would initiate a connection with the remote virtual machine. So this remote virtual machine can be in the local machine or it can be in a remote server. So first it initiates the connection. In the second step, it writes and transmits the parameters to the remote JVM. So we can see that it would do the marshalling process and transmit the information, tries to take the parameters that has to be passed to the remote object. And now the client stub would be waiting for the result. And once the server completes the process and sends back the results, this client stub would read, which we mean here is we will unmarshal the return values, or if an exception has happened, and it finally returns the results to the caller process. So this is what the steps that would be done by the client stub. And coming to the skeleton is an object that is available in the server side, and it would act as a gateway for the server side object. So all the incoming requests are routed through this skeleton in the server side. So when the skeleton receives the request, incoming request from the client stub, it actually does some of the process like read the parameters from the remote for the remote method. So some of the parameters to execute with the remote method would be passed from the client stub to the server stub. So this server skeleton, we call it as server skeleton. So this skeleton would read the parameters for the remote method, and then it invokes the method on the actual remote object available on the server side. And once the remote process gets completed, the data, the final result would be returned and transmitted to the caller by this skeleton. So, if you take the Java 2 SDK, a stub protocol was introduced that eliminates the need for the skeleton. So, we do not need a skeleton, but we need a stub too. Stub is like a handle that has to be available in the client side. So, without a skeleton we can have an RMI mechanism. Now, once the process of what the client stub would be doing and the server skeleton would be doing, we have a remote reference layer that is lying between the transport layer and the stub, and this reference layer is available in both the client side and the server side. So, this remote reference layer is a middle layer between the stub or skeleton and the transport layer. This is to support varying remote reference or invocation protocols independent of this client stub and the server skeleton. Now, coming to the transport layer, this transport layer is the lower layer that would ship the data. So, we now call the data would be shipped in terms of byte streams. So, where this is what called as marshalling of the data streams. So, this shipping of the marshalling streams would happen with the transport layer between the two address spaces. So, this transport layer is responsible for doing certain operations like setting up connections to the remote address space and managing all the connections, then listening to all the incoming calls, then maintaining a table of all the remote objects that that resides in the same address space, and setting up connections for an incoming call, then for locating the dispatcher for the target of the remote call. So, these are some of the responsibilities of the transport layer. So, the connection establishment and the maintaining of what are the remote objects that reside in the same address space, and setting up connections for the incoming call or locating the dispatcher for the target of the remote call, everything would be done by the transport layer. Now, so we have seen about the model of how this RMI mechanism is working. So, we have understood that a RMI mechanism would work between two machines, and there would be a remote method that would be running in the other end, that is in a remote machine, or it can be in the local machine but in a different JVM, and the one that is going to access this remote object is going to be called as the client, and we have seen that there are different layers by which this client and the server are interacting and making this remote method invocation happening. So, in order to write this RMI program, we need to maintain or we need to make use of two classes, two important classes called remote and serializable. But this remote is actually an interface. We need to first develop an interface, remote interface, by extending this remote interface. So, the class that for which you are going to create the remote object would be called as a remote class when it going to implement this remote interface. So, the remote object is a one whose instances can be used remotely. So, we need to have a handle to the remote object that would identify where the object is located and how to contact it remotely through this RMI. But when it is used locally, it works like any other object, like a local object. And when it is passed as a parameter, its handle is passed. So, it is like Java objects will pass the parameters of the remote object. So, there is another class called serializable class. So, the serializable is actually an interface, and the class the one which implements the serializable interface becomes a serializable class. So, a serializable object is one whose value can be marshaled, can be sent as byte streams from one end to other end. So, here it can be passed as a parameter or be a return value to a remote object. So, here the value of the object would be copied, and the class would implement an interface called serializable, which is available in the IO package. So, you need to make use of java.io, import the package java.io in order to make use of the interface called serializable interface. So, we need to make use of two interfaces called remote interface and serializable interface, and the class the one which is going to implement this remote interface or the serializable interface would be called as a remote class or a serializable class. Now, in order to make an object to be serialized, the class has to be declared as a public class. If when a class implements the serializable interface, the class has to be declared as a public class, and then the class should have a no argument constructor. So, you will have one constructor without taking any parameters, and all the fields of the class must be serializable, which we mean that we should not have any transient variables or static variables within this class. So, in order to support this marshalling and unmarshalling, we have to make the class as a serializable class, so that you can pass objects as byte streams from one end to other end. So, the class must be serializable, either primitive types or serializable objects, whatever you have should be serializable. And then we can see that what is going to be the difference between this remote interface and the serializable interface. So, a remote object lives on a different computer. Here we can say that it is our server computer, and we can send messages to this remote object and get responses back from the object, and we need to know that the remote object through its interface. So, and this remote object will not pose much of the security issue, does not worry about all these things. Okay. But what happens with the serializable object? So, a class which implements a serializable interface, and you try to instantiate an object for the serializable class. So, that object is now called as a serializable object. So, the purpose of the serializable object is to transmit the information from one end to the other end, or messages information from one end to the other end. So, the receiving object need to know how the object is implemented. So, it needs the class as well as the interface, and there is a way to transmit the class definition, and accepting classes will not pose a security issue. So, here the transmission of data would happen through the serializable object between computers, and a remote object is a one which would reside on a different computer or in a different JVM. And now we will see what are the requirements for developing a distributed application. So, we can call any application as a distributed application if the application has to locate a remote method, or it needs to provide communication with the remote objects, or the application needs to load the class definitions for the objects. So, in all these cases we can say that the application as a or we can call the application as a distributed application. So, this RMI has got all these features. So, now it is called as a distributed application. And now let us see about the steps to write the RMI program. There are basically 6 steps to write the RMI program. The first step, we have to create the remote interface. So, we'll see how to create the remote interface, and then the second step, we have to develop an implementation class that implements this remote interface. So, first we have to create a remote interface. By having an interface that extends the remote interface, we will have a remote interface. Once we get a remote interface, we will define a class that implements this remote interface, that would be the implementation class. And after we have an implementation class, we have to compile this implementation class. Once it gets compiled, it would generate a stub and a skeleton. So, we will use the RMI compiler, which is called as rmic, by which we will be creating a stub and the skeleton. And once the stub and skeleton are created, stub would be available in the client side and the skeleton would be available on the server side. We have to start, the next step, we have to start the registry service using start RMI registry. So, the tool we will use here is RMI registry in order to start the registry. And then we have to create and start the remote application. So, we will write a server side program and we will write a client program, client side application, and we will start the server first and then we will execute the client next. So, the client would be issuing a request to the remote object that resides in the server and would get back the result. So, these are the steps to write the RMI program. Now, we will see the steps one by one. The first step, we have to create the remote interface. So, here we need to know that we have to first import the package called RMI. So, this is an RMI package that is specifically available, within which you have all these remote interface. Serializable is available in IO. You have another class called unicast remote object. All these are available in the RMI package. So, first step, you have to import this RMI package, and then you have to create an interface, remote interface. So, we can see that we create an interface called adder that extends the remote interface. Now, this interface adder becomes a remote interface by which we have extended this remote interface. And this is an interface which will have only the method declaration and will not have any implementation of the methods. So, here we have one method called add, and this method would throw an remote exception. So, we declare a remote exception along with this method within this interface. And the second step, we have to provide the implementation of the remote interface. So, the implementation can be provided either by implementing by extending the unicast remote object. There is a class called unicast remote object, or we can use the export object method of the unicast remote object class. So, here we have actually used the unicast remote object class that is extended with the class called adder remote. So, now we had an interface called adder, we have created an interface called adder. Now, we implement a class called adder remote that is extending this unicast remote object and implementing the interface. So, this class is implementing the created adder interface. So, now it defines the method, the add method within this implementation. So, here the implementation is available, and as I told you, this implementation class should have an no argument constructor. So, there is a constructor which would call the base class constructor. The third step, we have to compile this implementation class which would generate the stub and the skeleton. So, use the RMIC compiler and give the implementation class name that would generate the stub and the skeleton. Once the stub and skeleton are created, we have to now start the registry. In order to start the registry, you start RMI registry. We have to give the port number where the server has binded the remote method. So, give the port number as 5000, that would be in the server program. And now you have to create the server application. So, here to create the server application, first we create an object of the remote interface, object of the class which we have implemented. The adder remote is the class. So, you create adder is the interface. We create a reference to the interface which would point to the object of the class adder remote. Now, this server has to bind this remote interface to the registry. So, we use a class called naming class, within which we have a method called rebind. So, using this rebind, we will be binding this remote remote object to the registry. So, the RMI is now here both the client and server are running in the local machine. So, here we have given as localhost, the port number is 5000, and we give a name called add, by which the client would identify this remote method, and we are associating this the reference of the remote interface here. And now we have to create the client application. So, the client would make use of a lookup method to locate the service that is running in the server side. So, we make use of the naming.lookup, same naming class, and use a method called lookup to look for the remote method. The remote method is binded with a name called add. So, give the same address and look into the remote method by its name called add. So, we create, we call, then using the stub, we call the add method and you will get back the result. So, here we can see that we start the registry, RMI registry running in the port number 5000. We compile it, RMIC compiler, that would generate a stub and a skeleton. Now, we have to start the server, start the client. We can see the client gets connected to the server and the result is displayed here. So, distributed garbage collection is automatic, like Java supports automatic garbage collection. For destroying all these remote objects, it supports an automatic garbage collection. And security, There is a problem with security with RMI. It does not have any access control, no authentication or no version control with RMI. So, this module we have explained about RMI, and we have also seen that how it differs from the other technology called CORBA, and we have seen about the RMI layers, and we have seen the steps how to write a Java program with an example. These are the references. Thank you.